It's really similar to what we were doing before. We're trying to factor. We're trying to break something down into two or three things that multiply to give it to us. Basically, what would be multiplied to give us that product. Except A is not 1 anymore. A does not equal 1 anymore. Before, it was easier because we could just look for what multiplied to be C and added to be B. We really just have one extra step to that part, and we need to think about how a GCF kind of relates this. The first step, if you can divide by a GCF, you can divide out the greatest common factor. That should be your very first step. It's going to make the rest of the problem a lot easier after that. If you can't, that's okay. Then we're going to basically just identify. We're going to identify the A, B, and C. We're going to identify the A, B, and C because we need to use each of those. Last time I'm going to do for identifying the A, B, and C. Because we need to use all of them in this case. Before, we didn't really care about A, we really just cared about B and C. Now we need to use that A and C because we're actually going to multiply them together. That's pretty much our first step. If you can't factor out a GCF, your first step is to multiply A and C together. That's what we're really looking for. That's what we're trying to figure out. So we're looking for what's going to multiply to be A times C now, not just C. Before we were looking for what multiplies to just be C. Now we're looking for what's going to multiply to be A times C, and that same combination has to add up to B. What adds up to B and multiplies to be AC. Actually, I'm going to show these steps one at a time so it makes sense of what I'm really talking about there. There is no GCF here. There's nothing that can factor out of that, and that. So I'm done with the first step. I'm going to identify my A, B, and C. That's A. That's B. That's C. I'm just talking about the number. It's just 4, 7, and -2. My next step is multiply A and C together. What is A times C there? It's going to be -8. Make sure you include the sign. That's -8. What is the B there? It's just 7. Really, it's just that number. Just 7. So I do A times C, and I just identify B. And this is kind of the same step as before. I'm going to rewrite this expression with 4 terms. We didn't do this part before, but the part that it's going to split into, this next step, it's going to split into this M and N. I'm going to split that middle term. I'm going to write this as 4 terms by splitting the middle term into this M and N. These two things that multiply to give me AC and add to give me B. What multiplies to give me -8 and adds to give me 7. -1 and 8. Those two numbers are how I'm going to split this middle term up. That 7 is going to split into a -1 and an 8. And keep the x attached to it. This is the opposite of combining like terms. I'm splitting that into 2 different terms. I'm splitting it into whatever numbers I used here. The reason I'm using those numbers is because they multiply to give me that, and -1 plus 8 adds to give me that. So I'm doing basically, it is the opposite of combining like terms. I'm splitting that into 2 like terms, -1 and 8. If you wrote it in the other order, don't write this part. But if you wrote it in the other order, actually I think my other 2 classes both wrote it in that order. Doesn't really change anything. that is the exact same thing as that. And you can continue with a problem like this. I'm going to continue with the one that we have. So that was step 4. We split that middle term. The next step, we want to group the first two terms and group the second two terms, and then factor them using their greatest common factor. When I say group them, I really just mean put them in parentheses. I'm going to put that in parentheses. I'm going to put that in parentheses with the sign. And that whole thing in parentheses, that whole thing in parentheses, and then I'm going to find the GCF of this, find the GCF of that, and then write those on the outside of the parentheses. What can I factor out of this and out of that? Richard, what can I take out of that and that? What can I factor out of both of these two? Eric, what can I? So you're right, 1, but really, actually, let's try that. 1 and what else? Really, there's a little bit more to it, Kalen. Yeah, just the x, really. I'm dividing each of these by 1x. The only thing they really have in common is just that x. You can divide by 1 also, but that's actually not going to really matter that much, but we can write that. I'm dividing this by x. That means I'm taking one of them away from that. That leaves me with just 4x. Really, I'm doing 4 divided by 1. That's still 4. And then x squared divided by x. I took one of the x's away. That leaves me with one of these x's still in the extent. I'm dividing that by 1x. What does that leave me with? There's -1 there still. I'm doing -1x divided by positive 1x. That still leaves me with a -1. The x's there completely cancel out. When you factor the second set of parentheses, it's going to be the exact same thing. Should be the exact same thing. It should be this exact same thing. This 4x minus 1 is going to be in the next set of parentheses also. What do I have to factor out of this to get it to look like that? Positive 2 is going to come out of there. 3 is going to come out of there. That divided by 2 gives me that 4x. These need to match. That's why I start off by writing that second set of parentheses. Once I figure out the greatest common factors from that, I write out this in the second set, and I figure out what I need to factor out of here to get it to be that. It has to be a positive 2. That divided by 2 gives me 4x. That divided by 2 gives me -1. And you're pretty much done once you get into that step. You just have to write your two factors together. 1x plus 2. The two GCFs make one of our factors. 1x plus 2. The second factor is in the parentheses. Whatever you get from here and here is the second factor. That's as factored as that gets. It's supposed to be confusing at the beginning. That is not a straightforward process. We're going to do a few examples together. Any specific questions about where any part of that answer came from? It's supposed to be a little bit confusing in the beginning. Don't just ask, I don't get it. Don't ask a big question. Okay, so that came from the GCF of this and the GCF of that. The greatest common factor from here came to the outside, that was the 1x. The greatest common factor from here was 2, that came to the outside of that, those two GCFs come together. Your first factor, actually that's what this line is talking about, that's really step 6, putting that together. Your first factor is whatever's in both parentheses. The second binomial or second factor comes from the two GCFs. That's really what that step was. You mean the A not equals 1? That part? What are you saying, sir? Really, this is factorable because that's okay. That is, those are, you don't have to write that one. You can just write it as 2 and 4x minus 1. That's okay. You can also write it in the other order. Those are both perfectly okay. You need to write that one. You don't need to write the one that's in front of the x. Yeah, FOIL that back out. Just multiply that back out with that, and you should get back up to this answer. Actually, it's just like checking before. If you FOIL, it's the exact opposite process. Actually, this is really the opposite of a lot of the stuff that we did. This is the opposite of combining like terms. That's the opposite of distributing. This whole thing is the opposite of FOILing. It's really just working backwards from what we've been doing. What can I do first on number 2? Yeah. Before I even do that. Yeah, I'm going to take out the GCF. What can I divide by on each of those? Yep, I'm going to divide by 2. Divide by 2. Divide by 2. So I'm factoring that to the outside. 2 times this whole thing. That becomes just x squared. The 2's just cancel out. That becomes 8x. This becomes 15. Okay. A is now 1 here. This is why you want to factor out the GCF. I don't need to use this whole process for that now. I factored out the GCF. Now I'm going to factor that just like you did on your homework. How can I multiply to get to that? And add to get to this. What 2 numbers can I use? Multiply to 15 and add to 7. What can I multiply? Yeah, 3 and 5 multiply to be that. They multiply to give me 15, and they add to be. They add to be 8. I still need to keep the greatest common factor on the outside. It goes from outside of all of that. That's as factored as that gets. When you have a GCF, that's when you're going to get 3 terms in there.
What happened to the 8?
The 8 turned into 5 times x and 3 times x together. Those add up to 8, and they multiply to give me 15. This is what you did on Blue for homework. They add up to that, and they multiply to give me 15.
That's the answer.
That is the answer. Yep. There we have 3 factors, the greatest common factor, and then these 2 factors. Take out the GCF first so that you can check to see if you need to do a lot more work or not. All right, what's our first step on number 3? What do I do first on 3? Yep. Yep, I'm going to times A and C. I don't have a greatest common factor. I can't factor anything out of those. So I'm going to do A times C. That's 5 times 8, or 40. What is B there? Sebastian, what's B?
Negative 14.
Yep. What combination of numbers is going to multiply to be 40, multiply to be that, and add to be negative 40? Yep. Yep. Negative 10 and negative 4. Multiply to give me positive 40, and they add to give me negative 40. That's what this is going to split into. This negative 14 splits into those 2 terms. 5x squared. It doesn't matter which order you write this in. You can write the negative 4 first, or the 10x. I'm just choosing to write the 10x first. That negative 14 splits into that, and that. And now I group each of those. I group these 2, and I group those 2. That's the factoring by grouping. That's what it's called. I'm grouping that stuff, and grouping that stuff, and then factoring. grouping that, and I'm grouping that, and I'm going to factor something out of here. The biggest thing that I can factor out of there, a little bit more. A little bit more. Yeah, really 5x. That goes to the outside of the parentheses. What's left inside of there? Charlotte, when I divide this by 5x, what do I get? Just x, yep. When I divide negative 10x by 5x, Jason, what do I get? Negative 2. This set of parentheses should show up again in our second factor. That x minus 2 should show up there again. I just start by writing that because I know that has to be there. And then I think about what I have to divide this by, what I have to divide that by to get to these two. What do I need to divide by that? Divide that by, really. Take that. No, negative 2 wouldn't get us down like, okay, let's just look at 8. That divided by negative 2. That wouldn't get down to that. What do I really have to divide by? That'd be a negative. I have to divide that by negative 4 to get it to turn into a 1. And I have to divide that by negative 4 to get it to turn into a negative 2. That means negative 4 is the thing that comes to the outside. Again, you're pretty much done with the problem. You just have to put those two factors together. This is one of them. The two GCFs combine to make one factor. And the thing that's in the parentheses makes the other factor. And that's our final. Yep. Yeah, if you FOIL this back out, you distribute that into there, you distribute that into there, you get this answer after you're completely done combination.
Wait, how'd you get negative 4?
That's coming from this negative. The GCF of that, the GCF of that come together to make that. It's not that's a good question. He's asking why is it not maybe that? Why are there not two of them? It's really because what I told you before was that this is basically distributing the 5x into here and the negative 4 into here. And that's really what this is showing. We're doing 5x distributed into there, and there's the color, but negative 4 distributed into here. That's really exactly what this is showing. This distributed to there is right there. This negative 4 being distributed into here is this step. We're just working backwards from that step. I'll explain that in more detail in our recording for fourth period if you want to go back to that again. I recorded third period also. I take a little bit more time explaining both in third and fourth period if you want to review those. Okay. I'm also going to post this to review any of those. Is there a greatest common factor there?
No.
So what's AC? Emily, what's
20.
AC there? So that's going to give us 20. And my B, so that's 2 times 10, 20. My B is 9. I'm going to keep everything the same, except this middle term. That's going to split into two separate things. What are those two terms? Layla, what are those two terms? Yeah, call that 4x and 5x. 4 times 5 gives me 20, and 4 plus 5 gives me 9. What's my next step? Ryan, what's my next step? splitting step. What do I have to do after that? Everybody else put your hands up. Brian, what do I do next? Okay, I'm going to group them, and then what do I do with this first group? What can I factor out of that group? A little bit more. You're right, there's next in there. So I'm going to factor 2x out of there and 2x out of there. 2x goes to the outside. William, what does that give me? Yep, that's 1x. Other William, what does that give me? Whatever you get inside the parentheses in the first set, that comes to this second set of parentheses also. It's also an x plus 2. What do I have to factor out of this to get it to be that x plus 2, Richard? Yep, it is.
And then 2x and 5 and then 2x plus
Oh, it's cheap.
2x plus 5 and x plus 2. Those are the two factors. The two GCFs come together. That and that come together to make this. The other one should be the easier one to find. That's just whatever's in the parentheses. That's it. Any questions on that?
Would the answer be 2x plus 5? Like in, I don't know. Oh, sorry.
That's your answer. 2x plus 5 times x plus 2. Questions on? Right. Look at this page. This is just special cases of what we've been doing. Everything that we've learned so far, you're allowed to use for these special cases. It just happens to be these kinds of answers. You're allowed to use, actually the thing that we just did, you can use for any type of problem. It doesn't matter if a equals 1, you're still allowed to use that. It's just you don't have to go through all of that if you recognize that a equals 1. Same kind of thing here. If a and c, get rid of that plus sign. It's not saying a plus c, it should say a and c. If those are perfect squares, if those are perfect squares, there's sometimes when you're allowed to use a trick to make this a lot faster. You don't have to go through the whole factoring by grouping that we just learned. There's a quicker way to do this. You're going to take the square root of the first and the last terms, the square root of the first term, the square root of the last term, basically, that's almost it. You're just going to put those together as the only factor. What's the square root of 4x squared? 2x. What's the square root of 25? That's going to make up our factor. 2x plus 5. And the other one is going to be another 2x plus 5, but I'm not going to write that. I'm just going to say it's 2x plus 5 squared. Those are the exact same thing.
That's the answer?
That is the answer. Yep.
Wait, what?
It only works when they actually add up to that middle term. There's sometimes where that's not going to work out. Even though these are perfect squares, it's actually not going to work out that they're going to add up to that. So this doesn't really work all the time. Okay? Really, you don't even have to recognize that. You can use exactly what we just did. The factoring by grouping will always work on this. I really want you using this shortcut. We'll get to that in a second. But this one doesn't always work, so it's not that reliable. I don't really want you relying on it to work every single time. This only works because we do 2x times 5. That's 10x. And then we do another 2x plus 5. That's another 10x. That's where that 20x is really coming from. It's those two 10x's that we get when we FOIL. We get that 20x. Okay? So this does not work every time. To recognize it, you can use it. Always check your answer to make sure you get that. This one's kind of similar, except we have a negative sign between. That's going to be important. What's the square root of 9m squared? What's the square root of 64? Those two are going to come together to make our but I'm going to keep it as a negative sign. Why am I doing that? Why does that have to be a negative?
Because,
Sounds what?
because, like, you put the square there.
So the squaring is going to make this a positive. Actually, this is always going to be a positive. In this special case, this is always going to be a positive. But why does it have to be a negative, Jason? Yeah, that negative 48 is basically why this needs to be a negative. It's the same kind of thing here. When I FOIL that out, 3m minus 8 and 3m minus 8. When I do the constant times the 3m, it's negative 24m and negative 24m. Those combine to make a negative 48. So if you notice that that's a negative sign, this also needs to be a negative. I really don't want you relying on that special case. The other one is much easier, and you can pick it out right away. Like here, you don't even know. You'd have to know that those are perfect squares and have FOILed it out to check that. Yeah. Oh, I'm sorry. You're right. That's to figure out our sign. Actually, that's what I was just doing there. Figure out what the sign should be based off of that middle term. Thank you. This is not that easy to pick out. These are really easy to see. When you don't have a middle term, when there's no B, you can always use this. This is going to work every single time, and it's a lot easier than using factoring by grouping. A and C are still going to be perfect squares. So they're still perfect squares. You're going to do the exact same thing. Square root of the first two terms. Now it's the first two terms. It's still the first and the last one. Square root of 9x squared and the square root of 16. Yep, what's that? And Jason, keep going. What's that? Yep. The only difference between this is that it's not the same thing twice. You're going to use 3x plus 4 and 3x minus 4. Yep, good. You can't do the square root of a negative number, so you get to algebra 2. But you're right, we get a result of a negative. Actually, really, we want to think about it like that. We're getting a negative answer there. The reason this is going to work out is because we do 3x times negative 4. That's negative 12x. I'm only showing the middle step. And 4 times 3x, that's a positive 12x. The reason that's working out to give us no term is because these are opposites of each other. They completely cancel each other out. There's nothing left on the inside. That's why these need to be opposite signs. They're the same thing, but just opposite signs. And if you don't recognize this right away, that's okay. You just need to treat B as a 0 here. So again, you can do factoring by grouping with that, and it'll work out the same. One of your signs is going to be negative, one of your signs is going to be a positive. That's the only difference between this and that. That's why we can't really write it as a square. So we don't have to do the whole factoring by grouping here. Where are the first terms going to be on each of those? William, what's going to be the first term on that and the first term on that? A little bit more. You're right at the 5, but you're doing the square root of 25 n squared. What do you get when you do the square root of n squared? Those are exact opposites of each other. Those just cancel each other out. This leaves you with 5n. So we have 5n there, and we have 5n. What's the second term on either of those, Tyler? Yep, 10. And I'm going to say the other one is a negative 10, so that we can get a negative 100 here. This also lets us do a different type of problem when we have two different variables. That's what you're seeing at the bottom there. Actually, this is the only way we know how to do these two. You have to do the square root of the first term and the square root of the second. Come on, what's the square root of that? Richard, what's the square root of that one?
1.
Sebastian, what are my two factors? What should I write in these parentheses? I'm putting those together, but not just 4 and 7. I'm putting them together like that. I'm going to write 4x minus 7y and 4x plus 7.
It doesn't matter what order, right? You can do 4x plus 7 times.
Yeah, that's fine too. You can write it as 4x plus 7 and 4x minus 7y. What about this one? What's that condition when I do the square root of x squared? William, what's that? Square root of x squared. Mark is x. What's the square root of y squared? 9y squared. Yep. Those two come together with opposite signs. X minus 3y and x plus 3y. On anything you did. I'm going to do one more on the back of this. I'm going to do number 6. Then I'm going to have you guys practice, and I'm going to have 2 of you come up and explain 10 and 11. So right now, I'm just going to do number 6. What do you notice about all 3 of those terms? Yep.
Greatest common factor is 2.
A little bit more than that. Yeah, x squared. 2x squared can come out of each of those. So I'm going to factor out 2x squared from all 3 of those. That comes to the outside of the parentheses. This turns into 3x squared. This turns into just 2x, and this turns into just negative 8. This looks like the problems that we were just working on. That we can factor using factoring by grouping. When we do that, this greatest common factor is going to just be in front of whatever factors we get from this. You take the greatest common factor out, it's going to be in front of whatever the final answer is. What am I going to do first to factor just the stuff inside the parentheses? That's not what I'm going to do.
There's going to be a just there.
Where? Oh, you're saying factoring out of here? Before you can do that, you have to do a times c. What's a times c there?
24.
Yeah, negative 24. B is 2. What combination of numbers multiply to be negative 24 and add to be 2? There's a combination there. Wait, look here. Yep, negative 4 and 6. Negative 4 times 6 gives us that. And negative 4 plus 6 gives us that. That's how we're going to split this up. 3x squared. I'm going to do the negative 4x first. Doesn't really matter. Negative 4x plus 6x minus 8. What can I factor out of these two? It's not now, it's what you're talking about. Just next comes to the outside of that. That becomes 3x minus 4. This is also going to be a 3x minus 4. What do I have to factor out of these two to get that 3x minus 4? Yep. is 2. Divide that by 2, divide that by 2. That gives me 2 on the outside. The 2 numbers on the outside come together and make 1 factor. The stuff in the parentheses is your other factor. This one really has 3 factors altogether. The greatest common factor that came out in the beginning, plus the 2 factors that we found by factoring by group. Everybody start with 10 and 11, then do the rest of the problems. I'm going to have 2 people explain them in 10 minutes, 15 minutes. Oh, hold on. Pick up.
Okay, so first A, B, and C, and then A and C together, and B is 9. And you can get things that will and 4, and they add up to make 9. And you group them. And then you can divide this by 5x. And you get and for this one you can divide both by 2. 2. And then you
How do we check our answer?
Boil.
We'll look back out, make sure you get that correct.
Okay, so first, and then you do A times B, which equals negative 24. And then B equals 2. And then 2 things that come out of negative 24 that add up to equal 2 are 6 and negative 4. And then you write it back out.
Oh,
And then you group the last 2 terms and the first 2 terms. And then something that comes out of both 8x squared and 6x is 2x. That gives you 4x plus 3. And then you take the 2 terms up front and combine them.
This is a multiple choice question on the test. You can always work backwards from the answers. If you forget all of this stuff, how to factor that, you can always work backwards just by following that back out, making sure that it gives you that.